I would like to introduce Sai Warang and give him a warm welcome for his talk. Thank you.
Thank you. I'm Sai, as it says on the slides. I work at a company called Shopify. I came here from Ottawa in Canada, and well, I'm really excited to be here. This is my first time in Hungary. It's actually my first time in front of so many people also. So to give you a little bit of background about what I'm going to be talking about. Sorry, I'm just getting used to the feedback. Thank you. I'll also give some time for everybody to get settled in. A little about Shopify in the meanwhile. Shopify is where I work. Shopify is making it easy for people to have to set up online commerce experiences. So anything from like an online store to like a point of sale at a fair, all of that. At Shopify, I work as a developer. I'm on a product team called Capital. In the simplest form, what Capital does is it finds merchants who are selling on Shopify, finds the promising merchants on Shopify, and gives them cash so that they can expand their business. Entrepreneurship is, as it turns out, pretty hard, and one of the biggest things that prevents merchants, like really ambitious people, from succeeding is access to capital, access to funds. And so Capital makes that happen. And Capital is entirely like a data-driven product, and that is how I ended up here in front of all of you. So Shopify has been around for about 10 to 12 years. It's one of the oldest Rails apps, and when it came into inception, it wasn't like a data-driven product or anything. It was an app that came into being to solve a particular problem. People wanted to set up online stores. They wanted to process orders. They wanted to have their customers check out, and they wanted all of that to just happen seamlessly, and that's what Shopify did for the longest time. In the process, for over 10 years, Shopify's ended up accumulating a lot of data. So data about merchants doing like real business on the platform. What that actually translates to is that we end up knowing what makes merchants successful, what makes merchants fail, and everything in between, because we get like front row seats into what's happening in the world of commerce, at least in the online hemisphere, like for the longest time. And so with all of that knowledge, we've been able to build a data-driven product, which is Capital, and that in the last year, since its inception, we've given out like $100 million out to about 5,000 merchants. So that's like a super rapid kind of growth over a short amount of time, and that has come with like a level of confidence in our data and what we've built. So, all right, without further ado, this talk is mostly geared towards people who like are working in like a legacy app that's been around for a while, that's been solving a problem for real users for a long time, and maybe at this point you want to make it smart, right? Whatever that word means. But this talk is kind of with that audience in mind, because if you're starting today, like a greenfield project or whatever, right, like something right from scratch, there's a lot of different tools that are available to you that you can probably structure your application to be such that you might not have the kind of constraints or the kind of problems that somebody working in an old app that has like real users and wants to expand on that might have. Of course, these most of the examples are like inspired by true events, which is the story of how Capital got built over time. And they've been kind of simplified for the sake of time and just to get the idea across. All right, so let's turn back the time to when like Shopify was not in a place where you could build Capital, for example. It was like a platform that like allowed people to sell stuff online, which is great. And it had this aspiration of making the whole process of setting up a business easy for merchants. So you wanted to be able to fund promising merchants. I'm just going to adjust this view a little bit. Give me a second. I'm back. And so yeah, I wanted to use the data that we already had, because we had this intuition that we have enough data to make something happen, and make the whole process of being on Shopify more pleasant, and give people some kind of unfair advantage for being on Shopify and us knowing everything about them. So here's what we had, right? We had a Rails app, right, that allowed people to set up an online store, process orders. The reason I bring that up is because when a merchant processes a lot of orders, they're successful. If a merchant has some kind of inclination of being successful, then we are able to make an investment in them. So those are the kind of things we cared about, and that's something that Shopify was already making happen. So right, so what do we have? We had a Rails app, model view controller. I mean, that is I'll do a quick rehash just so that we are all on the same page. A model is a Ruby class that has a certain behavior that mimics a real object, right? I mean, a user in a web app or something is a typical model, right? It has certain behaviors, maybe it can log into your system or whatever, and it's persisted, so you know all the users in your system. And again, historical data. So with respect to building capital, here are some models that were important for us to look at, a shop model. So the way Shopify is structured is such that different shops have their own records, and then every shop will have orders, and they kind of hang off of the shop. Easy peasy. Moving on, you have the controllers. This is where all the join logic will happen, right? And this is how you figure out what data is going to get presented, and you can have different consumers to your app, your different kind of views. Views again are just templates of they'll have the bits of data that we care about being presented to whoever cares, whoever's listening. This is relevant because we'll kind of come back to this. Oh, yeah, maybe that was me. The key thing about this is because it's separated in such a way that the views don't need to care about where the data that it's presenting comes from. And I think that is the little salient piece of thing that I want to kind of get across. And then, yeah, OK, cool. So we've covered MVC. Most people know this already. Meet my little friend, Skeptical Cat. Every time I have a thought where I'm talking about something obvious, or I'm trying to have a super pie in the sky kind of idea or plan, this guy usually shows up knocking at my conscience. So all right, so what's the problem? What's the big deal? This thing. We've just begun to expect a lot of the products that already exist, right? It's become common to expect Spotify to know what music you're into, Facebook to know what events you're interested in, Google to autocomplete your search, right? You want to automate repetitive tasks, and you want recommendations of you want some value benefit, you want some value add of having used your product. And specifically, what we cared about was the value add that we could give a merchant, which is figuring out which merchant is risky and which merchant is not risky to give money to. Because again, this is real money, and if you're giving money to somebody who is probably not going to be in a position to actually take off their business, it's not going to be a good time for anybody. So, so risky, not risky, cool. The other piece is okay, so let's say some merchant is not risky. How much money can we possibly give them? This is the classic underwriting, right? If anybody has any friends in banking, or if anybody is working in banking, underwriting. This is exactly what it comes down to. Whoa. And OK, so and the last piece is that we want to automate this. Like, we don't want somebody to just be sitting there, like, looking at all the merchants and like running queries and figuring out or like whether somebody's risky or not and giving them money. So like, this sounds like a classic data problem, right? So I mean, if we were to have this like pie in the sky idea, this is what it would look like. You would have a shop, and then you would just tell your like big Borg data brain to just tell you, hey, like, predict how much amount of money I can give this particular shop, this particular merchant, and that would be it. But OK, so is that possible with what we have today? Like, is that possible with what we had back then? Like a vanilla Rails app, you have like, it's doing everything that it's supposed to do. But if you want to ask it questions that, like such questions, you have to kind of, you have some heavy lifting to do somewhere, and it's not quite clear exactly where. So whenever I'm presented with a problem, I put on my thinking hat and think really hard. And then I like enter this text into my thinking hat, and out comes all these like amazing like logos, which are just like these like really cool projects that are out in the world that are doing like artificial intelligence and machine learning and like everything that's cool under the sun. And like I like to play around with tech, and so I like try to pull these tools down and like mess around with them in my spare time. That's great, but when I want to use these tools in a production environment, it has its like legacy runtime that like it's just not a great time, at least not right away. So actually, OK, so all this is coming up. Like this is interesting, whatever. But like, are we like kind of overshooting here? Maybe my little skeptical cat friend is saying like it's not like we can't process data in like your app. Like I mean, that's essentially what you're doing all the time, right? So like, what's the simplest thing you want? Like, do you just want like to know how many orders a merchant has? Just want to just do aggregations? You just want to have like maybe a background job that does this? I mean, that's totally a thing. You're doing that in a Rails app, or any web app for that matter. There's caveats. So one caveat that you'll run into if you are like an app that's growing, you have like a complex calculation that you're trying to do to like make your like add a value add to your product, which is great, which is very ambitious. But in the process, you're going to like run these complex calculations that you might not have fully thought through, that you might not have fully optimized, and you're quickly going to run into performance issues just with your production app. You're going to start dropping traffic for people that like your bread and butter users, and I don't think that's a good idea. But OK, caveat considered. Maybe you don't want to go that far. Maybe you just want like to have a presentation layer for your data. Like that's definitely a thing that's, I mean, you don't need to do anything extra for that, right? I mean, that's almost like baked into MVC. You have a bunch of data, you just want to have a dashboard for it. Like, OK. Can your data be trusted? If you want like a real dashboard that, like some kind of business process is going to be like based on that. Maybe you're going to do like accounting and financial reporting of your own business based on that data. Have you ever had test data in production? And have you had that like report spit those like test transactions out, which are like completely absurd amounts of money? That's happened to me. And so that's just like a really confusing time. So OK, maybe what we can do is like look at what we have and then like kind of compare it against different dimensions of like things we care about. So OK, we care about data quality. We want to do maybe some complex analysis or computation around it. And like for a stretch, we're going to do real-time predictions, which is like the like magic dream, right? Say. So like OK, we have a vanilla Rails app. Data quality, yes, but only if you're very careful. Only if you're like filtering out all the things that you like don't want to be like looking at when you're like productizing something. Always diligently, consistently. Great if you can do that. complex analysis, again, with your performance hits, and like you have like your code separated out into like this analysis and like the actual day-to-day functioning of your app. And we don't even get into like real-time predictions or any like kind of intelligence, right? Because like the most we can do is like we can hard code something. We can have like a model that's like some like fancy statistical model. You can hard code that in Ruby, and that's like maybe that's something you want to go with. But like again, you're locked into it till the next time you like do code review and change that. And as it turns out, with these artificial intelligence algorithms, let's say, you're like constantly testing them out. You're constantly experimenting with different versions. So like, good luck doing that if you are like kind of hard-coded like that logic into your production system already, right? So looks like what we've reached is like some kind of like frontier, right? Like there's definitely something out there that we need to look into that will help us do the things that we care about. And so let's kind of unravel that black box. Not that crazy. I propose that like the next kind of step is having a data warehouse. And really all that is like this fancy term of extract, transform, load. You're just taking your production tables out into another system. Like it gives you that like greenfield kind of like fresh feeling all of a sudden, because like all of a sudden like you're not dealing with like all the like legacy decisions and logic and like the like don't go there, that kind of stuff. You're like pulling all that data out, and you're taking periodic snapshots, and I'll get into that in a little bit. And you're sending it over to an external system, and guess what? You can also clean your data in the process. So like here's what an ETL kind of a simplified ETL flow could look like. You run a periodic extractor, and you keep a record of the last time a particular model or a particular table was extracted out. And if you have new records in your table since the last time you checkpointed, maybe it is time to ETL out into your external system. That way you know that your warehouse always has the up-to-date information. So here what we're doing is that we're looking at all records that have an updated timestamp that is greater than the last time we did a checkpoint for that particular table. So what that essentially ends up being is older records that have since been modified. Also, you get all the fresh information in your warehouse. Okay, cool. Other cool stuff you can do is you can filter out stuff that you really don't want to see, and so that way you're guaranteed to have like a clean data set, and that's outside your system. And since you're like checkpointing constantly, you're not like stressing out your production database just in the process of the ETL itself, because you're only looking at the freshest records. I know in Europe, like you're not supposed to keep a lot of like personal information of like transactions that happen. Like you can set a flag on your models that's like, hey, this is secret information. I do not want this leaking out and like staying in like my cloud forever. All of that stuff you can do, and like, okay, cool. Like that's looking promising. Like that, I think that gives us something. So, all right. You're not constrained by a production environment. And also, since you've moved out into another environment, you are suddenly you're able to look at like all those tools that we looked at, and we were like, okay, these look cool, but like if we were going to have them in your system right now, maybe there's no clear path. Now all of a sudden there's a way for you to like play around with that. Okay, so really, is that like enough? You just pulled out of the data into another system. That's like moving the problem elsewhere, right? So surely there's something more? I'm clearly a big fan of Interstellar. So the next thing that you like, if you want to like really make sense of that data, the next thing that works out or like has worked out for Shopify in the past is dimensional modeling. So here's what the main idea is. Your production app will end up having like join tables, right? So, okay, so I'll build an example that I can refer back to again. Let's say you have a shop, like a merchant that we just talked about earlier, and they have a bunch of orders, and those orders have like a bunch of different products within an order. If you wanted to see If you want to just look at all the products in your order, you're going to have to do just like at least a minimum of a join on your order, right? Like that's like the minimum level of SQL or just like writing Rails ORM that you need to have. OK, so that's what we have in our production system. But the idea is that dimensional modeling does not require you to do that. OK, so what else does it not require you to do? You don't have to follow the schemas of your production database at all. So what that means is like, most often, like the way you store your data while you're writing code is completely different from the way you actually think about your business. And so that's the whole idea of modeling your dimensions or your dimensions around your business domain. So again, to build upon that example a little more, what you really care about is how many orders, or what was the sales of a particular shop like every day of the last month, let's say. So you want to know like how much does a shop make like on Monday, then Tuesday, and so on and so forth. Now again, if you want to like, you can definitely do that in just like your conventional SQL fashion. But what if there was a way that you just had that information ready for you? And that's what dimensional modeling does. So it has like two principal components, like facts and dimensions. So facts end up being these numerical values or measures of like a thing that you care about. So like you have a business domain, and like that business domain, you measure whether you're succeeding or failing in your business domain by like thinking in terms of these like facts. And that fact just doesn't come out of like thin air. That fact gets computed based on a certain data points, and that is your dimensions. So all right, so you have a numerical value and a dimension. So what does that look like? You have your warehouse, right? And then, OK, so just like having the warehouse is like you've ETL'd those tables. That's cool. Now you're doing a certain kind of like meta computation on them. You're building dimensions, which is just, let's say, solid kind of representations of the actual data points that you care about. So, OK, let me kind of flesh this out a little more. So here's what I mean by that. What you can do is you can consolidate all your like tables, your production tables that you've ETL'd into your warehouse, and then create a ordered dimension that is like this fundamental kind of way of looking at orders that you can use for like all your further analysis. Let's say you had any. And so here's something that, like, let's say you want to give like money out to a bunch of merchants. This is what you would care about, right? You'd care about how they have been doing in the last, let's say, few days, few months, last few like X amount of time. So what would you care about? Like, what would you need for that? You'd need like some way to look at time and slice and dice your data by time. So that's like per day, per week, whatever. How successful has a certain merchant been over a certain period of time? What merchant it is in the first place? So that's that's your shop dimension. Orders are like actually what you're looking at. So like if a shop doesn't have any orders, then like they're probably not doing very well. Products are, again, what kind of products they're selling, what kind of like business are these merchants in. And lastly, like every product has like different inventory spread across whatever their shops. So you can kind of collect data from all these different dimensions, and you can compute a single like numerical value, which is like this shop has sold like 25 fidget spinners like every day for the last month, and they have been making $100 per day. Like that's a value that you can get in your fact table, and that's just like you can now go look at that fact table, and like all you have is just like rows and rows of just like actual data that like an average person cares about. The good thing about that is like now that just simplifies. So first thing it does, it gives you these like building blocks, right? That like you can kind of use in multiple different like ways of looking at your data. So like that's the like classic slice and dice mechanism. But you can actually automate that stuff. So before I get into a little more of that, I just wanted to kind of step back and talk a little bit, one extra point about dimensions that I wanted to cover was that, OK, so these dimensions themselves. So OK, so like how is this really different from like just doing joins on your production table, right? As it turns out, these dimensions end up being denormalized, which means that if you want to look at all the orders in, all the products in an order, and like you care about, like, let's say you're searching for the text like fidget spinner or something. So you can, or no other example is coming to mind. You could actually just have your order have that extra column of the product name, and so you never have to kind of drill deeper than that, like the very base dimension that you're using to compute your facts table, and which is why it ends up being called this like star schema, which means that like every fact table will just have like one layer of dimensions that you need to look at if you ever want to dig through exactly how that number is being crunched. So, I mean, of course, this is not all magic. You're obviously computing this in the background, but this just gives you a new paradigm of thinking about how you can build these products in a way that's, you know, sustainable, maintainable, and like easily understood by everybody who's interfacing with it. All right, so another thing that dimensional modeling helps you do is like really think about what you're doing. Here's a real world example. Okay, so like I mean, like you wanna get your product out the door, and so like sometimes you will like build stuff like in the quickest way, right? And like the surest tell of that is when you have like rows in a table with like JSON blob data. Like that stuff, like nobody can query, nobody can understand, but it's there because like, hey, you just wanted to capture this data, but you just did not have enough time to think through what exactly was going to be. So, for example, in Shopify, you have, it's possible for a merchant to kind of pack up their business and go away, or sell their business to somebody else. So what that ends up being is that like you have a merchant that like maybe qualified for Shopify Capital, but then they left Shopify for whatever reason. We want to be able to kind of like, if we're going to model this and if we're going to build a product around it, and we want to make it like, we want to de-risk it, we need to be able to like kind of pick that up in our dimensional modeling. But like the only record of that we had was just a generic events table with like a JSON blob which said shop 1, let's say, account owner changed, and all the information that you cared about was inside that JSON blob. So like that really forced you to like think about like, hey, what is going on here? Like there is an idea of an account owner changing. I mean, at the beginning of like Shopify, obviously this was not something that like happened often enough for people to like actually think about it. You just wanted to kind of make note of it and move on. But dimensional modeling is like an excellent place where like these kind of things will come up, and you'll be forced to revisit exactly like how you're going to think about your product long term. All right. Cool. So, okay. So then the last piece is obviously, as I mentioned, your experiments, your machine learning algorithms, all the like fancy statistical stuff. You're going to run experiments, and you're going to like try different algorithms out. Like 99% of them might end up being junk. Maybe one of them will be like the thing that like helps your business. You end up basically being able to do that on your warehouse, not in your production system, and keep like experimenting with the stuff, and have somebody who can just like be dedicated to doing that, right? Like you don't have to like have your like people who are like maintaining your site reliability folks care about all these like crazy expensive algorithms that are running on your production system. To learn more about how Capital actually does it, there's a blog post that I'm going to shamelessly plug. But I found it like, I don't know much about statistics, but I found it like pretty useful. Okay, so we're back to our little matrix. We clearly have complex analysis and data quality down with like just ETL and dimensional modeling, like doing that well. Okay, so like, I just want to take a second to kind of address the fact that like, okay, so this might not necessarily be like done in Ruby, right? Like at Shopify, we didn't end up using Ruby for this, but it's entirely possible to use HBase, let's say, for your data warehouse. And so today, I just found out that there's this whole like Red Data Tools, GitHub org, which basically has like Ruby bindings to interface with HBase. So which means that you can build a proper warehouse and potentially dimensional modeling logic on top of that, just in pure Ruby, which I thought was pretty fascinating. OK, so this is great. Like, you're doing a bunch of analysis that's outside of your production system. You're like learning stuff about your business. Cool beans. Like, how does that actually translate back to people who are using your product, right? Like, wasn't that the entire dream? Like, data is the new product, which means, like, as a user, I need to be able to see the fruits of that. OK, so you have an app that like you're beginning to like run a bunch of machine learning and stuff on, which is like great, right? What's the simplest way you can go forward and actually incorporate that data back into your app? Turns out, like, as a web developer who's already building web systems, like, it's not that complicated, right? Like, you already have a bunch of tooling that's like, every day it's looking at all the ETL data, it's generating dimensional models. On top of that, it's running a bunch of algorithms. Now it's generating a bunch of insights. You can get those insights, and you can definitely have like a web process that just like pings back your production app. OK, So, I mean, I just talked a lot about like JSON blobs in records in your production database. And here's like one exceptional case where it's actually OK to do. So remember how we said like our views don't actually care about where our data comes from. So if you have experiments that you're running where you just want to show a certain like algorithms data to a certain section of your users, it's very possible to have like these addenda records called like insight records that are just like data insights that your big brain is kind of pushing out constantly, and you can do your conventional join stuff on them, right? So you can look at like shop.join data insight, which means that like if I am running an experiment on my particular shop, I can get all the insights that are generated in my warehouse, dimensional modeling stuff, and I can get that back into my production app. I also get a like snapshot of exactly what data was generated and what my end user ended up seeing. So you also get like, again, you also get native Rails validation, because like maybe you want to have 2 levels of redundancy and 2 levels of resiliency, right? Like you don't want to trust everything that your data modeling experiments are kind of spitting out, because again, like 99% of the time it can be junk. OK, so we're looking happy here, mostly. Like we have real-time data predictions. Cool. So like this is roughly what our architecture looks like. I feel like the cat's going to come back and say, OK, so now you just like you had a bunch of complexity, and now you have a bunch of other complexity. So I mean, every system that we build that's great has its own ways of failure, right? So what can we do to mitigate it, right? Turns out, like, I mean, you can throw the like laundry list of resiliency questions at it, and it turns out like these are the kind of like the kind of problems that this introduces are just like web request throttling and web traffic resiliency that you already mitigate for when you're like building a production web app. So let's say your ETL process is broken. Like I mean, your ETL process did not run for that day. Like you could have a metric that fires. Again, what happens when your like APIs shift on each other? So like let's say you have your modeling process that's inserting insights into your app. Let's say that API changes. Again, you can have standard monitoring for that. The interesting one here is when your dimensional schemas become outdated. So here's what happens. like you have all, like you've basically reconstructed your world outside, right? Outside of your original world. And so if you introduce new columns or you introduce new concepts, your like reconstructed world is now not going to know what to deal with this extra data that it's going to get. And those are the common failures that you kind of you run into. And I mean, you can have some sort of infrastructure guardrails for this. The way we ended up doing was just shaming people who change things in your Slack. So Spy is our internal Slack bot, and so Uzi is this like whatever Apache Uzi thing, which like makes sure that your dimensions schema matches with the schema that it's expecting to find. And whenever it doesn't find it, it breaks, and the person who broke it knows that they broke it, and that's how you get everybody kind of just like learning all of this stuff by osmosis, but also making sure that this stuff like doesn't stay broke for long. And I mean, I think so. Yeah. So the second piece is when like the insights that are coming from your dimensional system cannot yeah, the validations that you have for your insights go busted. That's again like something that raises exceptions. So I mean, there's like these validations and these like figuring out how to deal with web requests that go astray is something that we're like as web developers we end up being good at that. So we're also able to like separate competencies in a way that you end up just dealing with the things that you care about and have somebody else who is super interested in like running a suite of algorithms on your production system kind of have it their way. Sometimes that's not enough. Like maybe you don't want if you want to maintain trust with your users, you don't want your users to like see something like you just became eligible for like $1 billion because that's what your algorithm spit it out. And if like maybe they go through the flow that we have automated completely, they will end up accepting this, and now we have to deal with this awkward situation of like, obviously we're not going to like give our merchant $1 billion, or maybe someday we'll be able to. That'd be nice, but we won't be able to do that, and maybe that is your last stand, right? Like any system that becomes automated will go through these like steps, and you will not have confidence in your automation right away, and you want to be able to like present some kind of human verification step at all points before you have the confidence to make something completely automated. And so again, because you have separated a whole bunch of calculation out from your production app, you get this like nice boundary, this nice like layered architecture, like where like it's literally like you're separated by the web, right? You have the HTTP layer. You can easily fit in an admin interface for a human being to look over this stuff. I mean, I love this topic, and I can keep going on and on about it. There's more stuff that I wanted to jam pack into this, but I only have 2 more minutes. So I would love to open this to questions. That's all I got.